For this question, let's first work on the expression of y, and we try to generate the expression for dy dx. It is given to us that y is equal to 2 minus 1 over x to the power of 2. And I'm going to rewrite this into 2 minus x to the power of minus 2. Okay, this expression is going to be one that is easier for us to differentiate. Dy dx, it is going to be equal to, if I were to differentiate 2, it is 0. So I will just need to differentiate this portion, which is minus of minus 2 x to the power of minus 3, which means that dy dx is equal to 2 over x to the power of 3. We want to find the y-coordinate of the particle, and this will involve the rate of change equation, and rate of change is always rate of change at a particular instance, which means that at this particular instance, we want to find the y-coordinate of that particle. And the instance that the question is talking about, it is when the x-coordinate is increasing at 0.12. That means it is when dx dt is equal to 0.12. We want to find the y-coordinate of the particle at this instance. It is also given to me that the y-coordinate is increasing at a constant rate of 0.03. So dy dt, this is equal to 0.03. This is given by the question. And if I were to quote the rate of change equation, that means dy dt is equal to dy dx multiply by dx dt. And in order for us to find the y-coordinate of the particle, let's first try to find the x-coordinate of that particle, because if I were to be able to find the x-coordinate, I just need to resubstitute that back into this expression. I'll be able to find the corresponding y-coordinate of that particle. And I can do that through the rate of change equation that is here. This is given to me as 0.03. This is given as 0.12. So this, which involves x, will help me to form an equation in terms of x. So let's try to substitute all the values in so that I can solve for that value of x, which means that from here, dy dt is 0.03 and dy dx is 2 over x to the power of 3, and this is multiplied to dx dt, so 0.12. This is that equation in terms of x. We will try to solve for x. That means x to the power of 3. This is equal to, if I were to use my calculator, this is 8. So x is going to be equal to just simply 2. With this x is equal to 2, I'm going to substitute back into this equation to find the corresponding y-coordinate. So the y-coordinate will be 2 minus 1 over 2 square. And this is going to be equal to 7 over 4. And that is why the y-coordinate of the particle at this instance is 7 over 4.